back, students. Now we are having a problem in front of us. Now I really wanted to solve a little bit complex problem so that whenever you can actually pick up your textbook, maybe your new school physics or anyone, you can pick up any of your textbook and solve. You have a lot of textbook to use. We have new school physics, we have comprehensive physics, everything. Anyone, just pick anyone and solve questions under it. And please, you can watch the video and watch it again if you don't understand. But this question here, we have the what? Now, the first thing you need to know in physics is that whenever you are given a question, you need to write out your parameters. Your parameters is a guideline for you in succeeding in solving the problem. Now we have that what a body is projected from the ground at an angle of theta. They didn't give us theta. To the horizontal, that's the angle of projection, theta. They didn't give us. With a velocity of 30 meters per second. Now I told you that what a body will always move with what? An initial velocity. So your u is equal to what? 30 meters per second. So we have it that what? It reached the maximum height of what was our maximum height there? Our maximum height of 11.25 meters. So we have h max to be what? 11.25 meters. They now say that what? Calculate the value of theta. That's 1. We don't know our theta. So now we know that what? Our maximum height is equal to what? U squared sine square theta over what? 2g. So our maximum height is given as what? 1.25 is equals to what? Our u squared is what? 30 all square, and we don't have this sine square theta over what? And you know your g. Take your g as what? 10 meters per second square. Sometimes they might give it to you, sometimes they might not give you, but you know that your g is a constant. So we have it as what? 2 times what? 10. Alright. Now, let us write that out. We have it 11.25 equals to what? 30 square sine square theta over 2 times 10. So we are looking for the angle of projection. So your subject of formula is applied in math. So I used to tell students that what? You don't, math and physics, they go in together. Because if you want to actually, you love physics and you don't like math, you will be frustrated. So please, you must be very good in math, even most especially further math. So further math is very simple. So what do I have here? I have it as what? 11.25 to be what? 30 square is what? 900. And we have sine square theta over 20. What do we do next? We cross multiply. So we have it 11.25 times 20 equals to 900 sine square theta. As you can see, so we want to make our sine square theta the subject of formula. We have it as sine square theta equals to what? 11.25 times 20 over 900. Then I want you to punch your calculator. I want you to punch your calculator first before I will give you time for you to punch your calculator first. I'm coming. So I'm very sure that you have actually punched your calculator, and I'm very sure that you know how to punch calculator. you have this one multiplied by this divided by this. Now in your calculator, you type this first, multiply by 20, you open the bracket, 11.25 multiplied by 20 divided by what? Now, these ones will be in bracket and you put what? 900. Because if you do it directly, sometimes your calculator might actually solve it and you will get a wrong answer. So do it that way. So we have it as what? Sine square theta. Now, in this sense, I told you, if you remember, that what sine square theta is also what? Sine theta all square. So I can put it there. Sine theta all square equals to 0.25. So when I have this, I want to make this sine theta to stand alone. I what? Root both sides to remove the square. Root both sides. So what do I have? I have that what? Sine theta square equals to what? The square root of 0.25. And I have it cut out. So sine theta will now be equals to what? The square root of this is 0.5. So what do? I'm looking for the angle of projection. So I have it that what? For me to look for, that would be what? Theta equals to what? Sine inverse of what? 0.5. Which is what? Theta becomes what? This is 1/2, which is what? 30. Yes. 30 degrees. So the angle of projection here is what? 30 degrees. Now number 2, they said that we should find the what? Time taken to strike the ground. Time taken to strike the ground. Meaning that what they are looking for, the what? The time of flight. The time of flight, which is what? We have it as t equals to what? 2u sine theta over g. So the time taken is also what? To strike the ground is also what? The time of flight. So we have it as what? 2 multiplied by what? Our u still remains 30 multiplied by what? Sine 30 over what? 10. So our t is equals to what? We have it as what? 60 multiplied by what? Sine 30 over 10. So we have it as what? 60 times 1 over 2. 0.5. So we have it as what? So the answer is what? 3 seconds. So that's number 2. Now, the second to the last, they said that the range, you have your range to be what? U square sine 2 theta over what? G. So your range becomes what? 30 square sine 2 multiplied by 30 over what? 10. So your range, so I want you to take your time to solve this using your calculator, and when you solve it, you have 900 multiplied by sine 60 over 10. Then when you cut and you solve, you arrive at 77.94 meters. Range is also like distance or displacement, so please, you need to note that. That's the answer for that. Now the last one, we have what? They said the velocity, its velocity 2 seconds after projection. Its velocity 2 seconds after projection. That its velocity, let me write it out. Its velocity 2 seconds after projection. Now, its velocity 2 seconds after projection. Now, when you project, meaning that it moves up. Now, you notice that what? They want to know after this 2 seconds after projection, if velocity at this particular point. How do we know? Now, it's very, very simple. I told you that what? What changes? What is constant? We have the horizontal ux to be what? Constant throughout, and we have the what? Uy to be changing, it varies. So this one have a velocity at this point which varies. So at this particular point, what we're going to be using there, we are going to be using uy. So that will be uy u sine theta. Are you getting me? So that what? Uy equals to what? Y 30 sine what? 30. So uy equals to what? 30 times 1/2, which is what? 15 meters per second. Answer. Very simple. So we're going to be looking at the horizontal projection. We're going to be looking at the horizontal projection. The horizontal projection. So please, I want you to look at those workings, go through them, write them down, and try. Now, we are going to be looking at horizontal projection. And at this projection, this involves a body projected from a horizontal platform. As you can see, it involves a body projected from a horizontal platform. And at a given height, h, at a given height, this kind of projection involves the body initially at rest and with a constant speed. Initially at rest and with a constant speed and a constant downward acceleration. Please, I want you to put that down. It involves a body initially at rest and with a constant speed and constant downward acceleration. Now, we have it as this, as a constant speed. As you can see, a constant horizontal velocity or speed. And a constant downward acceleration. So, at this particular point, we have what? Our range. So, please, this is the horizontal projection. We actually finished the vertical projection. So we are going to be looking at how we can work this out and how does this thing actually work. Now, we have that what from the equation of motion, we have S equals to what? Ut plus half AT squared. At this particular point, we are still dealing with downward motion. Your A changes to what? G. But it's coming down now. At this particular point, if you remember from there, they said here that what? The body is formally at rest, meaning that what is at zero and started projecting downward. So there is an increase in velocity. So it will be positive G, not negative G. If there's a reduce in velocity, it will be what? Negative G. But at this point here, we are using a positive G. Now, what is our U? Our U there will become what? Our Uy. Because I told you, in a parabolic pathway, what changes is what? Your vertical component. It varies. It varies. Your Ux is still left constant. Now, we are going to be considering two aspects. We want to look at the height. We want to look at the height and the what? And the range. The range. So, from here, let us see how the height works. Let us see how the height works. Your S here changes to what? Height. Now, at the height there, at the height here, we want to know our height. So, how do we recognize our height? We know that what? Our U there is what? Our U is what? At what? 0 because it started from what? Rest. From what I read to you. I said that what? Your U is what? At rest. So it's what? 0 meters per second. Are you with me? So now, we have that our A is equal to what? G. And the time to reach the ground still remains. So we have it there as what? H equals to what? 0 times T plus what? 1 all over 2 gt squared. So the formula for finding the height in an horizontal projection is what? Half gt squared. Please note. Half gt squared. That's the formula for finding the height in an horizontal projection. The one that we have there was in a vertical projection in our previous class. But this one is what? In an horizontal projection. When you thereby stand in a tower and you try to throw something downward, you notice that what? The height here is what? Half. It actually requires what? Acceleration. It depends on the acceleration due to gravity. And it also depends on the what? The time taken in reaching the what? The ground. Now, let us look at what? The range. That is for the height. For the range. Now, we notice that what? For the range, we have that what? The body, our acceleration at that particular point is what? 0. It doesn't deal with what? Acceleration due to gravity. We want to look at the distance from the foot of the tower or the hill and the what? The point of it striking the ground. We want to look at the distance. So we know that what? Our distance, our acceleration due to gravity there is what? Is 0. Now, let us go back. We are still going to be using that same formula. At this particular point, what is constant? Left constant is what? Your U becomes your what? Ux. Because I told you that what? The horizontal component there is constant throughout. So let us put it there. So therefore, our range now is equals to what? Which our S is what? Range. Our range now is what? Ux, the time still remain, plus what? Half 0 times t squared. So this one goes out. So we have it as R equals to what? Uxt as our range. This is our range. While this is what? The height. So if they say that you should find the height of the body, the object projected from the height of the body. If they say you should find out it, we have the height and we have the what? The range. So I'm going to be giving you a series of questions and OBJ questions and theoretical questions so that it can aid you in all these that we've done. So this is the end of projectile motion. I want you to make reference to your textbook and also ask questions from the WhatsApp platform or anywhere that we are going to be making contact. So see you in the next class. Thank you. That's what you do.
Pause didn't stop. Pause didn't stop.